Okay, hello everyone. Welcome to today's lecture. So today we are not going to cover any new material, but I have released a practice exam, so we can go through that exam and try to solve it. But before we start that, there are some announcements or some information which I want to share to make sure that everyone gets this information. First thing is about the midterm exam one logistics. So the date is okay. Someone's mic is not muted, so please mute yourself. So the exam date is September 30th, and it will be during the class hours. That is from 13:30 to 14:45. It will be in the room SH118A, which is basically our classroom. We have not been using it, but it is reserved for us. It will be paper pencil based and will be in person. So you need to be there in the classroom. The exam will not be online. So please make sure your attendance. And the syllabus will be all the slides covered in lectures dated from 26th of August to 23rd of September 2025. So this was about midterm exam one. The second thing is about project one module A. So it is also released, and I think I made an announcement on Canvas if I remember it correctly. I also made a video to explain what you are supposed to do. There is a text description, but trying to make it more clear, I have made a video and I have posted it also on the Canvas syllabus page, right? So you can go and watch that if you need to. Okay, so with having said that, what we can do is for today that you guys can actually I have uploaded this PDF, which is basically midterm exam one from the previous offering of the course. So there are some questions which I think they are like kind of comparatively easy. So, for example, the first question, which is about okay, let me read the statement. Oh, okay, let's not do like that. So what we can do is, okay, I give you like time. For example, let's say I give you 2 minutes or 1 minute to read the question, and after that we can take it from there. So go ahead and read the question one statement, which is also showing currently on the screen. Okay, if you have read the question and you want to respond, go ahead. Go ahead. You can unmute yourself and you can try to respond.
Say that Robert's choice is good because DRAM is volatile, so the bootstrap would be lost.
I can barely hear you. Can you please try to get a bit more closer to your mic?
I'd say Robert's choice is not good because DRAM is relative, so the bootstrap program would be lost when the power is off.
Yeah, yeah, that is correct. So since DRAM cannot hold the data persistently, and when that power is removed, the data is lost. So when you like reboot the machine, bootstrap program will not be there, and as a result, we will not be able to load the operating system, right? Okay, so is there anyone who doesn't agree with that statement or whose opinion is different? No? Okay, so then let's move to the next question. So you have like read the question and then we can talk about the answer. Okay, yeah, you can scroll down. Let me scroll down too so that you can see the full statement of question. So if you have read the question and you so first thing, if there is anything, if there is like any ambiguity or you are confused about the question, let me know. And if everything is clear, uh, then try to answer the question.
So would you just modify the memory address of ISR memory to let's see, ID2 is address 3, the same one as network adapter?
Say it again. I didn't get you clearly.
Would you just because let's see, it says you have access to the memory. So if you could just move ISR memory controller, move its address to address 3, wouldn't that do what we're looking to do? Because then anytime we get address 2, we're actually modifying what should be address 0. Or am I
Eh,
understanding that incorrectly?
Yeah, yeah, that is one way to do it. Yes, that is one way to do what the attacker wants to do. Uh, but is there? I'm not saying it is wrong. You
Okay,
can do
then
that.
just making sure I understood the question.
But
Cool.
is there an more is there
Yep.
a more efficient?
Is the
Yeah.
interrupt vector
So I
considered
think you were
like,
saying like you can copy. Yeah, go ahead. Go ahead.
sorry, is the interrupt vector considered like pointers to address places?
Yes.
So then in that case, could you just switch address 1 and address 3 or
That
put
too.
as well?
Yeah, yeah, yeah. That is the second option. So the first option, the first way you can do it is like what the first student said, which is like what you can do is, for example, we want to invoke the interrupt ID2 when the actual received interrupt ID is 0. So what you can do is like, let me draw if I can. So copy the whole code of this body of the interrupt ISR memory controller interrupt routine into this one, right? So what happened is that when interrupt ID 0, oh no, no, sorry, the other way around, the other way around. So which is basically copy everything here, right? Copy here, copy this whole code, whatever is written here, copy it and paste it here, right? So what will happen is that when the actual interrupt ID is 0, so control will reach here, but the code which is pasted here is basically the code for the body of interrupt service routine for network adapter. So this is one way. The other way is what the second student said, that instead of like doing this copy, you can simply change the addresses. So when the actual ID is 0, so we can here, instead of writing address 1, here we can put address 3, right? So when actual ID is 0, the pointer will point to this location, right? So you simply need to redraw the figure. So for example, let me show how I have, sorry, somehow I need to exit from, yeah. So if I go, so this is the second approach, what the second student said, simply overwrite address here, and that's all you are done. Right? Is it clear? Anyone who is still confused or have a question?
Makes sense to me.
Okay. Okay, so then let's go to the next question, which is, yeah, what is mode bit used for? And can user level code modify the mode bit? Justify your answer. Anyone who want to respond?
So the mode bit is whether it's a user program or a kernel program, right?
Yeah, it is to distinguish between the two code spaces.
Mm-hmm.
Yeah.
Then what else? If I remember right,
So,
the user cannot modify the bit.
okay, why not?
Or because of restrictions or something like that. I'm trying to remember the specifics.
But what is the motivation behind having those restrictions? Yes, there are restrictions. I'm not
Right.
saying
The
file.
motivation behind the restrictions
Yeah.
to prevent unwanted access or something like that.
Yeah, unwanted access because we don't want a user application to set the mode bit to 0 and then pretend like as a kernel level code and do the malicious things.
Right. Okay.
Okay.
I have
Uh,
a quick question about that.
okay, go ahead.
Right. I think I asked this in a previous class, but so what's the difference between like a user running sudo then compared to like they technically still don't have that mode bit activated, or they would while running
Yeah.
sudo?
No, they still will not have that. User cannot never have the mode bit set equal to 0, which mean having the kernel level access. No, but sudo is basically about giving you privileges for running some operations or some tasks, but it doesn't mean that your code it becomes or your application. For example, let's say I simply wrote, right, actually I was doing this right now. I suppose I wrote a bash script, right? And then I put the restriction that you need the sudo level privileges to run that script, right? But that script is still a user level program. Uh, and if I say that if in order to run that script, you need the sudo level privileges, it doesn't mean that if I enter my credentials and then I'm able to run it, it doesn't mean that I'm running the kernel level code. I'm still running user level code, right? So it doesn't change the mode bit to 0.
Thank you.
So I have a question.
Yeah, go ahead.
Can you hear me? Yeah, so now they said, what is mode bit used for? Can user level code modify the mode bit? Justify your answer. So if I want to justify my answer and I said user mode cannot modify mode bit because it doesn't have the privilege. So it's only when we are inside the kernel mode that we can modify the mode bit. So does that justify the answer? I know you give a different answer, like the reason, the motivation is what you give. So can I say something like that and still get the full mark?
Yeah, what you are saying is an answer to the question like, can user level code modify the mode, but uh, you are saying, okay, there are restrictions and that's why user level code cannot modify it, right?
Yes.
Maybe I need to be more explicit here in my question by saying justify your answer or comment on the motivation uh, behind whether a user level code is allowed to modify or not. If I want you to give me the motivation instead of like what are the implementation restrictions, right? So yeah, I mean it depends how you interpret the question, right? But again, if we end up in a gray area where your understanding of question is different than mine, then we can again we can always discuss it. And as I said, after every assessment item in the course, we are open to having an objection session where you can say, okay, I understood the question like this. So that's why I answered it in this way.
All right. Thank you.
Yeah. So let's go to the next one then. Again, these questions are like kind of theoretical questions. So complete the following process state transition diagram by naming each state. That is each oval in this figure, right? So do you want me to do this? I think even offline you can go and you can check the lecture slides and complete it, right? So let's not waste time on this question. Okay, so let's come to this question 5. So it says, let me go to the slide because for this question we have slides, we can use them. Yeah, this one here. So here it says, draw the process tree that will be generated by the following code. Assign each process a unique ID, starting from 1, and present a process by drawing a circle. Use an arrow from circle A to circle B to show that process A is of process B, parent process of B. So, how can we do this? Actually, the same way as we have seen in our lecture slides. So initially, you have only one process, which is basically this main process running, right? And when you reach at the point where the fork is invoked, so at that point, a new process is generated. So this new process, which I'm naming as 2, and then it is child of the first main process. So I'm simply indicating it by putting an arrow between them from 1 to 2. This child process 2 has exactly same address space as that of the parent. And when I say exactly address space, it means they are not sharing the address space. The address space of both of them are different from each other, but the address space of the child is exact copy of the parents, right? So then when both of them start executing, for child PID will be equal to 0, for parent it will not be equal to 0, right? Here. So the parent will not be able to enter this if block, so it will reach at the end of the if and it will be stuck in a infinite while loop, right? However, the child will enter the if block and it executes another fork, right? So when it executes another fork, a new process is generated, 3. So since 2 is parent of 3, we have an arrow here. And then the child 3 or the process 3 again has exact address space as its parent. So the program counter is also same, right, as its parent. So pointing to the same location. So after that, when both of them execute, for child PID will be equal to 0, but for parent it will not be equal to 0, right? So child gets stuck in this infinite while loop while parent continues to the code after the if block. So at that point, uh, when the fork is again executed, which means a new child is created, and this is the child of process 2, not of process 3, right? And this child or process 4, it again has exact address space as its parent, having program counter pointing to the same location. Now for child PID will be equal to 0 and for the parent it will not be. So child enter the body of the if block and gets stuck, and the parent doesn't enter the body of the if block and goes to the statement after the if block, which is again an infinite loop and gets stuck there, right? So we have this uh, process tree when we execute the initial code. Any question here?
Yeah, I noticed that you finished off one in the beginning. It doesn't matter the order you go into, like keep going in the code. Does that make sense? Like on one, it created the child number two, yet
Yeah.
it continued as you continued with one instead of moving on to two afterwards. Does that make sense? Does the order matter?
You mean at this point or next
Yeah,
point?
so right there, and like child two is about to create a new child or the grandchild, but
Yeah.
as well as number one is ending in the forever loop, right?
Yeah. So it will be stuck there, right?
Yeah, but they're happening simultaneously, correct? Like as it's going
Yeah,
down.
we are, yeah, either they are happening simultaneously if you have if you assume multi-core platform, and if you assume a single core platform, then they are, they are sharing, they are time interleaved, but it doesn't matter. Even if they are time interleaved, if you allow process one to continue, it will always be executing while one, but when it will be kicked out and process two will be allowed to execute, it will create a new child. Did I answer your question, or I'm answering something different than what you
Yeah,
asked?
that makes sense. And then also, if can we have the parent process be zero? Does it matter, or do you want it to start with one?
Yeah, it was just a convention. Like I wanted everyone to start with one so that it is easy for me to grade to grade the solution. Right? You can start from anything, but I just wanted to like, because if let's say if someone is starting from number 100 and another student is starting with 50, it will be a little bit difficult for me to keep track of things. So that's why I started. Everyone starts with one. Are we good? Can we continue with the next?
Yeah, thank you.
Okay. Okay, so uh, let's go back to our exam. Okay, so this time, instead of actually after I have shown you the solution for the previous question, I was thinking I should have asked you to try to find the solution on your own, and then I could have shared the solution. But let's do this for now for question 6. So try to answer this, and you have 5 minutes. Okay. What will be the output of the following code snippet? Oh, sorry. Let me know if you like, if you are ready with the solutions, let me know.
Is it gonna be z equals 6 and then z equals 9?
So there will be like two outputs, z equal to 6 and z equal to 9.
Let me just explain.
Uh, Give it a second thought, because if you are saying like there will be two output statements, z is equal to 6 and z equal to 9, then you are missing something. Try it again.
And so I have, we can have 9, we can have 12. So, but one thing is confusing here.
Yeah.
Like you said if the parent have wait, like the parent is waiting for the child. So then if you have wait, then it will wait for the result of Z, which we will now later add to 3,
Mm,
making it 12.
no.
But here there is no dot wait.
Yeah, there is no weight, so
So,
it will not be
so
valid.
I'm saying 9.
You are saying 9.
Yes.
So you are saying only there will be one print statement, which will be z is equal to 9?
Because I believe unless probably we are using probably they specify that the child will execute before the parent. But yeah, there is nothing that guarantees that the child will execute before the parent. If the parent is faster than the child and there is no wait, probably
Yeah.
we'll have the result of the parent before the child.
Okay. Okay. Let's
So
let's hold it there and let's wait for other students. So it's good that you guys are like having different answers, which basically means like you are struggling with something. So I can address it when I present the solution. Uh, yeah, but let's wait for some other people to uh, try to solve it.
Yeah, I have a question about it. Is like, does it matter if the processor has multi-thread or not? Because I'm assuming like they could, if there's multi-threads, then the processes are running at the same time, right? So there's a chance that the child could finish before the parent or vice versa.
There are no threads. This is a single threaded process, right? We have not, and even for example, in our course, in our lectures, we have not yet seen how we can create threads. Have we? No. We just in last lecture we started talking about threads, but we didn't talk about how we can create the threads. And in this course, sorry, in this code, we are not creating threads anywhere. We are creating a process. Fork, when we say PID is equal to fork, that is creating our new process. Okay, Asim, go ahead. You can unmute yourself.
I have a question. How do we determine?
Please get closer to your mic. I can't hear you clearly.
Can you hear me now?
Yeah, a little bit better, yes.
Okay, I just had a question. How do we determine if the parent or the child finishes executing first? Like, is order something that's um important here, I guess?
Here, this code is not putting any restrictions, right? Here, for example, parent is not waiting for the child. So it's mean it all depends upon the scheduling by the OS, scheduling of the processes by the OS. So we don't know which one will go first.
So it's non-deterministic.
It
Child
can be
can
it
finish
can be
first.
anything. It can be anything like parent can finish execution before the child or child finishes execution before the parent.
Okay, got it. Thank you.
Okay, someone sent a test. Would there be three prints? Statement 9, 6, and z equal to 12. Yeah, Jade, you are right. So, okay. I think we had a good amount of discussion. So let's go to the solution then, right? Okay. Okay. So here is the question. Uh, so let's start follow the same approach. So until this point, there is no fork. So z is equal to 3 plus 1 plus 2 plus 6. I simply plug in the values, these x, y, and z. So z is equal to 6, right? And until this point, we have only one process, main process, right? And then we say PID is equal to fork. So which means a new process will be created, a child, right? Let's say the main process, parent process is process 1, child is, I'm giving it IT2, right? And then both have exact like the address space of the child is duplicate of the address space of the parent with the same value for program counter. So for child, PID will be equal to 0, but for parent, it will be not, right? So it's mean that child will enter this if block, but parent will reach at the end of the if block, right? So with that, so let's say that both start continuing their execution. So it's mean that here, if I go back, so here, what you will see is that Z will be printed, right, by the child, right? I don't know if you can see my pointer or not. Let me, here, Z will be printed by the child, right? And then when the parent continues his execution, it updates the value of Z. So here when Z is printed by the child, it will print 6, right? And here child, when it starts its continuous execution, it updates the value of Z in its address space. So new value for of Z for parent becomes 9, right? And then it says print FZ, so it will print 9 here, right? And then it returns 0. On the other hand, when child continues, it again updates the value of Z. So the value of Z here, it updated it here and it was 9. It updated here again. So this time it will become 12. And when it says print, so it will become Z is equal to 12, right? So we will have three outputs: Z is equal to 6, Z is equal to 9, Z is equal to 12. And order is not important. Why order is not important? Because as I said, it depends on two things. One, let's say if you have a single core, so it's mean only one process can run at a time. Now we don't know, or at least in the context of this question, we don't know which one will be given the chance to run first, right? So that's why the order is not important. The second, even if there are multiple cores, so both of them are printing on an output device, which is the screen, right? So even if they are running at the same time, but when they reach their printf statement, so basically they are making a system call to write the output to the output device or screen or display, right? So only one of them can get access to the device. So again, in the context of this question, no information is given that how, if there is a competition or there is a, how to say, conflict, which one of them will win. There is no information is given. So we can assume like anyone can go ahead and print. So that's why order is not important. Any question? No question? Okay. Okay, so okay, now yeah, try to solve question 7. You have 5 minutes. And yeah, in this question, I haven't given the equation for M-Dalsra, but if an exam, if we have a question about M-Dalsra, I will put an equation there, so you don't need to memorize it. Just I'm just giving you information, okay? So you don't need to like memorize it, but you need to know how to use it. So if you want to solve it now, you can like go back to the lecture slides and get this equation from there.
For the execute time, do we just put 1 if I remember right? Or trying to remember.
For execution time, yeah, we actually in that equation we assume that total execution time is 1. So 1 actually represents
Okay.
100% execution time. Yeah.
Right, because it's more of a a ratio or percentage of how fast it is as opposed to an actual value. Okay.
So 100% is 1, and let's say 50% is 0.5. Okay, one thing which I just like, it came to my mind and I want to talk about it before I forget again. So, the project one module is released as I said, but let me, yeah. So, project modules, they need to be done in the groups. And what I saw here that there are some students who have not made any groups. I mean, they are like they have not teamed up with any other student, right? So uh, if I don't know if it is appropriate to call out names at this point or not, but if you are attending this lecture and you have not made a group with another student, let me know right now, okay? So that we can fix this issue. I don't want you to work individually. I haven't, okay. So okay, so yeah, this is what I was going to say, that in the sheet you can see there are some other people who have not made a group. So maybe you can directly contact them and uh, you can team up together, right? So please coordinate with each other and try to make the groups. I don't want to like make a, how to say, force group. So coordinate among yourself. Yeah, please coordinate, and then once you have agreed to make a group with some other student, so then update this sheet. Or I think it is still editable. So go and edit it, and if you cannot edit it, I think there is no restriction, but if you cannot edit it, then send me an email with both students in the group, with the name of the both students in the group. I hope it is clear now, right? So please do it, and as I said, I want you to do work. I want you to do these projects in groups. Okay, so let's go back to the. Okay, is there anyone who has solved this question 7? Anyone who has solved this question and want to share the solution?
For the first one, I got 1.8 speed, and for the second one, I got 1.97 speed.
Speed up, okay. Yeah. Okay, so actually that's good. That's good. But what I have seen is like even during the class and today now, even today, there are like couple of students, like 3, 4 students who are responding to questions. I will encourage you everyone else to also participate. Even if you have some, if you are not confident about your solution, still go ahead and share with us. You never get any negative points for sharing some wrong answer. It's fine. Everyone is learning here, right? So don't be shy. Okay. Yeah, so let's have a look at then at the solution then, right? So yeah, it's like kind of pretty straightforward. I don't know what you said, 30s is the same as what I get, but if not, you can simply check here. So if it is two cores, so S is equal to 50%, so 0.5, 1 minus S is 0.5, N is equal to 2 because we have two cores. When you
Ah,
put in the values, you get 1.33.
I got my S wrong. I see where I went.
So your S2 was your two cores answer is
So
like
where you've got 0.5 plus, I put 1 plus.
1 plus. Here, here.
Yeah, here I put 1 instead of 0.5 on the left side of it. So
Yeah.
not the parentheses. I got the parentheses right. It's just the left side of that little formula I got wrong.
Okay, okay, okay. So, okay. So as I said, I will just give the formula in the exam. Okay. If we have a question about NDAL, so you don't need to memorize it. So, but you need to know how to where if S is 50, then 1 minus S or parallel part is 0.5, right? And for 16 cores, everything else is same. Only the numbers of core change from 2 to 16, and when you plug in the values, you get 1.88 times speed up.
And I
Okay.
guess to check my understanding, so the S is the amount that can be parallelized, or is the S what is serialized?
S is the part of the program which is serialized, which can never be converted into a parallel form.
Okay, so that's why it's 0.5, not 1. Okay.
Yeah.
Thank you.
Yeah, and 1 minus S, so whatever remaining left, so you subtract serial from whatever total, so will you come up with the parallel part, right? So 1 minus S is parallel part. Okay, any questions else? Any questions here? If not, we are done with the questions of our midterm exam, right? No questions?
The 50% stands for the parallelizable, right? Not the serial.
Yeah, here it is okay. Let me explain. Forget about these values. S is equal to 50 and 1 minus S. Let's focus on the formula itself, right? If you want, I can actually go back to the slide of the previous day. So okay. So here is what we want to do. So we want to find out that if instead of a single core processor, we use a processor with multiple cores, and then we run the same program which was running on a single core processor. If we run the same program now on a multi-core processor, how much speed up, or in other words, how much performance gain we will get, right? So Amdalda, this actually helps us to answer this question. And for that, we first need to understand that the program can be potentially consisted of two parts, not in like terms of like coding, but in terms of like which part of the code it can be parallelized and which part of the code can never be parallelized. So we can never come up with an algorithm which do the exact same thing, but in a parallelized fashion, right? So conceptually we are like dividing our program into two distinct parts. The part which can be serialized and the part which can be parallelized and the part which cannot be parallelized, or in other words, which always remains serial, right? So it needs serial execution. So yeah, you can bring calculators, yes. Okay, so assume that like when you are running your program, when you were running initially on a single core processor, we don't care how much time it was taking. Let's say even it was like it was taking 100 seconds, but we will treat it as a one time unit, right? So we'll convert 100, we say that 100 is equal to one time unit. Even if let's say it was taking 1000 time unit, we still consider it as we are actually doing the normalization, right? I don't know whether you guys are familiar with normalization or not, but what we are saying is that when we were running our program on a single core, the time it was taking, we on the single core, we considered it as a one-time unit, right? Now, S is the time to execute the serial portion. So remember we said, again, let me go back and make it like kind of more easy to understand. So let's say you have a program here, right? Right? And you have a processor which has only single core, core 0, and you are running on this program on the core, right? And it takes some time. I don't know what is the exact value or for that time, but I am indicating that as the as serial time. And let's not say serial time because it will become confusing later on. Let's say single core time. Single core time. The time you get when you run it on the single core, right? So when you run it on the single core, the program is guaranteed to be executed in the serial fashion or in the serial mode. Why? Because if you have a single core, you can run only one thread at a time, or you have one sequence of execution at a time. So there is no parallelization, right? Everyone agrees with me? If not, let me know. If you think I am talking something rubbish, let me know. Okay, so now this SC single core time, it can be anything. It can be, I don't know, it depends upon the program. It may be it is 100, it is 1000, it is 1 million seconds, whatever, right? But whatever it is, I'm saying I will treat it as equal to 1. Okay, why I will tell you, but for now, trust me. Okay, so now let's say I analyze this program and I say, okay, some portion of this is can never be parallelized, and I'm naming it that portion as serial, right? So whatever else is left is 1 minus S, right? So if S was the time, if it takes S unit of time to execute the serial part, right? And the total time is 1, what will be the time to execute the parallel part? Parallel part time. Parallel execution time, right? If total is 1, right? And
Right,
the second
everything
part
except
is
for the serialized part.
yeah, so it will be 1 minus S, right? So remaining part, this one, 1 minus S, it can be parallelized, right? So we define it as so 1 minus S is the time in the initial execution, single core time execution, which can be converted into the parallel form, and hence that's why it can be run simultaneously on n cores, right? So which basically I'm saying I can allocate this to, let's say, different threads running simultaneously, and each thread then runs on a different core, right? So here if I have 3 cores, 3 threads running on 3 cores, so it will be 3, right? Is everyone with me or not? Please respond if you understand or not. Even if you don't understand, let me know. I can give you more concrete example where I can write an actual code for, like, let's say, instead of this thing.
I can understand, no worries.
No worries. Okay. Okay. So, uh, so this is how you come up with this equation, right? So S is the time to execute the serial portion. 1 minus S is the runtime of the portion that can be parallelized. Since we can, these extra codes, they can be helpful only for the part which can be parallelized. That's why we divide only 1 minus S by N, right? So because this is just like we are dividing the work to multiple workers. So we are dividing 1 minus S is the work which we are dividing to N workers, and workers are the cores, right? So more cores you have, we expect to have more speed up. However, if the available work is itself very small in size, it doesn't matter how many worker you have, you will see very small speed up. So for example, if there is only one bucket of dirty clothes to wash and I have 100 washing machines, and each washing machine, let's say, at least takes 5 minutes. So it will not be as much helpful as compared to if I have, instead of 100, only 2 washing machines, right? Because if each one of them take 5 minutes, then I'm using 500 minutes, right, to finish the job of cleaning, let's say, one bucket consisting of 100 dirty cloths, right? But if I compare it with 2 machines, so then if they take like only two, each one of them take 5 minutes, so it will be much faster. Okay, so now let's go back to our today's lecture slides. Do we still have time? We still have some time available, so no, let's not go to the threading sport, because I don't want to start this new topic at this point, because then it will be like, fragmented, in the sense that we will cover that. Actually, the thing is that threading sport, like how the threads are implemented, there are two basic ways. They can be implemented either at user level or at the kernel level. So if we now discuss about what is the mechanism for implementing threads on the user level, and what are the pros and cons of this approach, then when we will come back after the exam, which will be like 1 week from now, then you will be like totally disconnected from this part of the question. And because after the exam, we'll be discussing how we can implement the threading sport at the kernel level. So you will not be able to like compare and contrast the two approaches. So let's stop here then. Okay. So then start preparing for the exam. We will have it on 30th September, which is, I guess, Monday, or not Monday, Tuesday. Yeah. Yeah. So, and if you have any questions before exam day, you can always send me an email, and I will also have office hours on Monday, so you can also join them online, right? Zoom link for office hours available on the Canvas page. Good luck for the exam, and if there are no more questions, then that's all for now.
Yeah, I have a question.
Okay, go ahead.
So you said in that fork program that we just saw, so you said the parent takes data that return
Let me
from
go
the
back.
children.
Let me go back to the question. Are you referring to this question? 6?
Yeah, something like, yes, this is an example. So you said the parent takes the return from the child if there is dot weight, right? Through the dot weight. So, but on that slide, you still mentioned that once there is fork and we enter the child, so the memory of the child, the data, the place for the program, that data segment is loaded with the child program. So from, let's say, after this one, we have 2, which is the child. So the program will load
Okay.
from,
Now explain your question. Yeah.
yeah, so the program from these 2 will be loaded into the program section of the child.
So here, two is the child and 1 is the parent.
Yes. So after the fork, so once we enter this 2, which is the child,
Yeah.
so the next thing is the program from this 2 will be loaded into the child, the program section. Right?
Yeah, it is already loaded at the time of fork. Once the fork is done. Yeah.
So
okay.
how does the parent now takes the data from here? Since you said both those address are not the same, like we have a replica of the parent, but the address where the data is stored, like the stack and everything, is not the same. So how does the parent now know of what the address contain, like the value of the address? Do you get my question?
Extremely sorry. I couldn't get your question. That's why I was sorry for that. Yeah, say it. Yeah.
Z is a variable, right? So Z
Yeah.
will be pointing to a memory block.
It's a memory variable. Yes. Okay.
Yes. So the memory will contain a value. But in the real sense, Z in 1 is pointing to a different address. Both Z in 1 and Z in 2 are not pointing to the same address, right?
No, they are not the same. They are not pointing to the same location memory. They are different locations in memory. Yes.
Exactly. But this one is using fork.wait to wait for the result of this. So how does it know the result of this when it doesn't have access to the value this Z in 2 is pointing to? You don't get it still.
I'm still not getting you.
Okay, let's say Z in 1 is pointing to memory A.
Okay, let's do something like something which actually will allow. We have time, so don't worry. So let me simply copy and take it to the notepad. Okay. Okay, now tell me. So you are saying, okay, yeah, both of them will have their own. So I'm here actually drawing their address space, okay? To like, so this is process 1. And this is process 2, right? And let's say this is stack. I'm writing only S for stack. And this is stack for process 2. So it will have its own variable Z here, and it will have its own variable Z here, right? So for Z, so initially Z is equal to 6, right? So when fork happens, an exact duplicate is created, right? So it will also have Z equal to 6 because P2 is child, right?
Yeah.
Now go ahead and tell me your question.
So when we are executing 2, Z becomes 9.
In parent or child?
In child.
In child. Okay, let's see. So we come here. So it prints Z is equal to 6 and then it computes this one, right? So Z becomes 9. Yes.
So if I didn't mean that we have dot weight here. You know, this particular example, there is no weight, right?
No, there is no weight. If there is a weight, for example, the parent will say, for example, let's say after fork, I don't know, let's say here, if I put weight here, so then parent will execute all this and then it will wait. If I put a weight here after 4, right?
Okay.
So then parent will create a child and it will wait before executing anything else. It will wait for the child to complete all its execution. And once it is completed, then parent will continue.
Now, so when the parent is about to continue, how does it get the value of Z equal to 9?
No, parent will not get Z equal to 9 because This Z is equal to 9 is in the address space of the child, this one. So remember, when fork happens, the address space of the parent is duplicated. So it is everything thing is same, but it is different address space. So child, they don't share their address space, right? So that's why once the child starts executing and it says z is equal to z plus x plus y, it updates the z variable in its own address space. So parent doesn't see it.
Okay, so which data is now this dot weight? Which data is it getting?
Who?
Because it is stated that the parents use dot weight to get the data from the child. So which
Oh,
data
no,
is it
no,
getting?
no. Parent doesn't use the weight to get data from the child. No, the job of weight is not to get data from the child. The job of weight is only to when a process calls wait. For example, if here parents calls the wait, it means I am waiting for my child to complete its execution. It doesn't mean that I am waiting for my child to send me data. No.
Okay.
I think
So
you misunderstood how wait works.
so both are completely independent
Yes.
from the fork. Okay.
From the point where the fork happens. So again, if you let me like to do it again for you. So here you have P1 initially, right? So it has a variable status equal to 0. This is in stack section, this status variable. It has a variable x which is set equal to 1, right? Here it is a variable y set equal to 2, variable z set equal to 3, and then when this statement executes, z becomes equal to 6, right? Are you with
Yes.
me?
Yes.
Okay. Okay. Now there is no other process head until this point. We are here, right? Only we have process P1. Then we say do the fork. When you do the fork, process P1 is created and its address space is not the same address space as P1, but is duplicate of the address of the space of the P1, right?
Yeah.
It is copy of, right? So here it
Yes.
also has its stack, and in its stack, it also has exactly same things. Status is equal to 0, x is equal to 1, y is equal to 2, z is equal to 6. However, this x is different from the x in the address space of P1. Y in the address of P space of P2 is different than the y in the address space of the P1, right?
Yeah.
So now if, for example, parent makes changes in its z variable, let's say I'm just making it up. It sets z equal to 100. It doesn't mean that this z in the address space of the P2 will also be set equal to no. It will still be
Yeah.
6.
Yeah.
And vice versa. Let's say child sets y equal to 20. The y in the address space of the parent will still be 2.
Okay. So what is now dot weight doing?
What is what?
Just to what is in this particular example, if you have dot weight, that means we still have the same result,
Yeah, so
the
if
same printout.
yeah. Okay. So now let me simply change this example, okay? So let's say I cannot write it here. Yeah, these are figures, I guess I cannot write. So let's say I give me 1 minute. Yeah. So let's say I change this example, right? And I say like here after fork I'm putting weight, right? So now what will be the output? Everything else is same. I'm just putting weight. Okay. So to make things, so here for parent P1, we have, I'm writing only stack. Status is equal to 0. X is equal to 1. Y is equal to 2. Z is equal to 6. And then you say fork. So P2 is created with the exact same values. So status is equal to 0. I think some other students have messages, but let me finish this one, then I can take care of your messages. X is equal to 1, Y is equal to 2, Z is equal to 6, right? And then parent is waiting for the child to complete. So it's mean execution of parent will not continue until the child is done. So the child says if PID is equal to 0, so yes. So it enters this body, right? It enters here. So it prints. So let's say this is our console. So this is console, our display screen, and it says Z is equal to 6 is printed, right? And then it says Z is equal to Z plus X plus Y. So which becomes equal to 9. So here you get 9, right? And then you reach here and it says Z plus X plus, so it becomes equal to 12, right? And then it says print F12. So it will become Z is equal to, it will print Z is equal to 12. And then it says return 0, which means now the completion, child is completed. So its execution is completed. Now, only after this point, the parent can continue execution. Now, if parent will continue execution, it will get PID equal to not equal to 0, right? So it will reach here and it will say Z equal to Z plus X plus Y. So it becomes equal to 9, right?
Yeah.
And then it says printf, so it will become equal to Z equal to 9 here. Okay, now what is the difference from the question in the original question? In the original question, there was the order was not important. So if in your solution you had written, let's say Z is equal to 6, Z is equal to 9, Z is equal to 12, some student, let's say, wrote this output. Another student write Z is equal to 9, Z is equal to 6, Z is equal to 12. Both are correct. But here in this question, order is important. Only this is the correct output. Any other order will not be accepted as a correct output. Why? Because parent must wait for the child to complete.
All right. Thank you.
You're welcome. Okay, so who is this? The team list can be found in the syllabus tab in Canvas. Scroll down and then, okay, I think you are trying to help each other, right? The question 2 of the practice exam midterm, it just duplicates address 3. It just duplicates address 3 code to the position of address, but the main address 3 still remains same, right? Like just copies the code to address 0. Yeah, that's correct. Precious, you asked the question and you are asking that the content of the, I think you are referring to, where is the solution? Yeah, I think you are referring to this one. You are asking that this address 3 will remain same. Yes, it will remain same. Let me know if I answer your question. Where do I find the team list again? Okay.
Yes, thank you.
Okay, thank you. Sounds good to me. Yeah, you can find them on the syllabus page on the Canvas. Okay, okay. So, anything else?
I
Where
have-
will the exam be?
Sorry,
Where will the exam be?
exam 2. Yeah, midterm exam 2. It will.
The upcoming one. Will it be
Yeah.
on? Like, where will it be? Like on campus?
Oh, okay. So yeah, it will be on campus, and as I said at the start of the lecture slides today, it will be, and I also made an announcement on the Canvas, so please check that. So it will be in room SH118A.
Okay, thank you.
You can see the slides, right?
Yes, sir.
Okay. Anyone else?
Hi, I had a question. So I
Yeah.
just wanted to make sure that the exam questions will be based on, or they would be similar to the slides examples. Like if it just reviewing the recordings or the slides will be enough to prepare for the exam.
Yeah, slides will be enough to prepare for the exam, but actually it's good that you asked this question, and I wanted to make this announcement, or I wanted to inform you. Don't expect me, like, for example, if I have in this practice exam and a question about Ahmedabad, then it is guaranteed that it will appear on the exam on 30th of September. Or let's say if there is a topic which is not covered in this practice exam, it doesn't mean that it will not appear on the actual exam. I cannot put the questions related to all the topics which we covered in the practice exam, right? So, but the purpose of practice exam is just to give you an idea of the level of difficulty or what styles of questions we can have. Like, for example, if you had an understanding or expectation that there will be MCQs or true and false only in the exam, then no, you will not have only that type of questions. Maybe you will have those questions, but MCQs are true and false, but they will be not the only type of questions on the exam, right? Again, I am free to include questions from other topics which we have covered in the class, but which are not covered in this practice exam. Okay.
So we should be expecting like the implementation of what we have learned, like the real life problem, then provide solutions, not something like list and the likes.
Say it again, sorry.
So we should be expecting the implementation of what we have learned. Like all this slide, it's just like you are giving us a problem, then we are applying what we have learned, right?
Yeah,
So
yeah.
we shouldn't be expecting something like list 5 different types, something like that.
No. Even if I ask you something like, for example, which is theoretical, like, but I don't like, it will be something which will be like very obvious, right? So, for example, what is difference between multi-core and multi-core processor and single core multiprocessor, right?
Okay.
So you don't need to, for that, you don't need to memorize a paragraph from your textbook,
Thank you.
right? Yeah. Anything else? No? If not, then that's all for now. And start preparing for the exam. Good luck for the exams. See you again on Tuesday online. Okay. I will be
All right.
available. Exam will be in person. I will be available online.
Cool. Thank you.
Thank you. You're welcome.